All right, my name is Dan Bartlett. I'm in the ET program, and this is my final project. I am making a motion-detected solar-powered floodlight with battery power. The concept is we have a solar panel, and then it's going to come into what's called a buck converter, and that's going to transform the voltage from the solar panel, which is going to be 12 volts, down to 6 volts to power a battery pack. Because that way we can have a smaller battery pack, and that way we have less space in the overall package of the light. And then it's going to go, it'll be using a motion sensor, and that'll detect a person that comes in by the motion detector. It'll turn the light on, and then it'll act as a floodlight for people walking down a path, or if it's in front of your garage or something like that, when you pull in the driveway with a car. So the big part of the project is this buck converter. So that is going to, like I said, take the 12 volts from the solar panel and then transform it to 6 volts. And so what that's going to do is then be able to power the two motion sensors, because we're going to have two, so that way we can have a wider area. It's also going to power the microcontroller, and then it's going to charge the battery itself. And then the 6 volts is actually going to come from the battery and go to what's called a boost converter. And then that'll power the LED floodlights, because those are actually 12 volts, so we need a little more power. But it's easier to have to convert it back again, because then, like I said, you can have a smaller battery and less space. So the benefits of the buck converter, what it is, it's a switching power supply versus a linear, and that way it has a lot more efficiency, like 85% or more, and so it doesn't waste a lot of power, and so it can convert it from the 12 to 6 a lot more efficiently. So the schematic for my board for the buck converter is pretty straightforward. It's got the 5-pin chip here, and then I have to have, this is just a filtering capacitor for high frequency. This is a diode right here we have to put in, and then another capacitor and an inductor, and those three we had to calculate for. And so the inductor is 112 microhenry, and the thing that makes that special is it actually has to be a very low resistance for the coil. And the capacitor itself is 27 microfarad, and that also has to have a low ESR, or equivalent series resistance. And then these two resistors right there, those are just the feedback, and that's what controls the output voltage from the chip. So you have the 12 volts coming in here, comes into the chip. The feedback controls what the voltage of the output is, and then it comes out, and then it goes through the inductor and then the capacitor, and then it can go out to the battery. And then what I have is up in the corner up there is just a power circuit that goes from the battery to both of the motion detectors, and then also the microcontroller. So this is the layout of the board. We've got the 5-pin chip in the middle. We've got the two resistors. These are terminal blocks, these 5. The one in the far corner there, that's going to go to the battery, and then we've got the 3 they're all the same, so 2 of them are going to be for the motion detectors, and then one's going to be for the micro. And then this one right here is the input. This is coming from our solar, and then it's going to go right directly into the chip. And then you got your filtering capacitor right there for high frequency. And then you've got the inductor, your big inductor, and then you got your capacitor. So this is a picture right here of the 5-pin chip, and this is actually on my board that's all cut out. Got to assemble that. But this is what it's going to look like. This is a 150 kilohertz 5-pin chip. It can handle up to 1 amp of current through it. So that's that. So this is the full circuit diagram of the project. So like I said, the solar's gonna come in, go through the buck converter. It'll then transform it from the 12 to 6, then go to the battery, and then it'll branch off, go to the two motion detectors, those are the PIR sensors. And then it'll branch off to the microcontroller, which then will take an input from the motion detectors, and then we'll take and send an output to the boost converter, and then that'll turn that on, which will be powered directly from the battery. It'll send a pulse from the micro, turn the boost on, and then activate our floodlights, which there'll be 2 of them. So this is a picture of the motion sensor right here. It's a 3-pin module. It's got power, ground, and then the middle pin is the output. It's a 3.3 volt high that when it senses motion goes high. The thing that's very interesting about this one is it's got a very wide range of operating temperatures, minus 15 to 70 degrees Celsius, which is really important for this project because it's going to be located on the side of a house or garage or a building of some sort. So it's going to have to take a lot of temperature ranges, either in a direct sunlight in the hot summer day or in the middle of January when it gets really, really cold, or at night. The range of the actual sensor module is 140 degrees, and it's about 5 to 7 meters or so. And it also runs off of between 5 and 20 volts, so that works with the 6-volt battery pack. That's really going to be ideal. This is the waveform, what it looks like. It's about, I have it set, there's a adjustment screw on it, and you can adjust it from about 5 seconds to about 18 minutes. I have it set on the 5 second because I don't really need a long pulse to detect. It's just that instant pulse. So I have it set on 5 seconds, and then it goes up just up to 3.3, and then 5 seconds later, then it drops down once there's no more motion. This is a picture of the boost module right here. It's another 5-pin chip, and it's got capacitors and inductors on it. This chip just has 2 pins like this, and 2 pins on the other side, and it's just got an input and an output. But what we found is that one of the pins on the boost chip, on the 5-pin chip, is an on-off switch, and so what we're going to do is cut that pin and then connect it to the microcontroller. And that way I can keep it connected to the 6-volt battery pack at all times. And then the micro will send a pulse to that pin and then engage the buck converter. That way we don't have to have like transistor, and then that'd be more losses across the transistor and resistors and all that. So it just lessens the circuit and it makes it more efficient. This is a picture of what it is potentially going to look like. You've got the solar panel up here. You've got floodlight, in my case it'd be 2 like that, and then you've got the motion sensor, and there's going to be, like I said, 2 of those. But the benefit with this is it's going to be an LED, 2 LEDs, so it's going to be a lot more efficient than traditional halogen like this. But it's going to be like that one. It's going to be mounted on a house or a barn or a garage, something like that, facing out like on a driveway or a walkway. And then what it'll do is in the daytime, the solar will charge the battery, and then at night when you want to use it, the battery will power the light. Any questions?
Do you think you're going to run into any issues with the range and your motion sensors?
Well, the thing is, that's why I decided to put 2 in. That way I could compensate for the range. Because, yeah, it's got a wide angle, but the distance, like I said, it's only like 5 to 7 meters, so it's not quite as long as I had wanted. But, because see, I probably ran into trying to figure out finding different sensors. Some had a longer range, but the problem was they didn't have a good operating temperature. They were only good to like 0 degrees Celsius or something, so they couldn't handle the really cold weather. And so these were the best ones I could find. So that's why I decided to add 2 instead of just 1.
If you go back to the full circuit diagram,
Sure.
so I didn't catch everything you said when you were describing that. You were kind of telling the sequence, yeah, that one. So what is the micro doing in this process?
So it's gonna take an input from the motion sensors, that 3.3 volt, that's gonna pulse a high, that'll go in, so the micro will detect that, and then it'll output on another pin, it'll send a pulse to the boost converter, turning that on, and it'll stay high, and then what I'll do is I'll put a time circuit in on the micro and do like 10, 15 minutes, something like that. And then, so this will have, it'll initiate a timer, and then it'll send a pulse to the boost, turning the boost on, and then count that timer about 10, 15 minutes, and then stay on, and then shut off, which will then shut the lights off.
Would it, well, it seems to me that the infrared detectors, the motion detectors would do all of that for you.
Right.
Is there something else you could do with the micro, as long as you have it there, that would be more interesting? Could you come up, seems to me like you could do something, either flash the spotlights,
Right,
or,
right.
you know, and that's the advantage of having a micro, the circuit, you can
Right.
do more than what you can buy at the hardware store.
Right.
So, for purposes of, you know, showing me something, yeah, have it do at least what you said, but
Right.
I think you could probably do some interesting
Mhm.
things, maybe turn on, although you have both floodlights running off the same boost.
Right, right, unless I got two separate boosts, I could do that.
Yeah. Yeah, if you could sort of use the motion detectors, as you have two of them, to sort of track the person, or come on in stages, or flash the lights
Right.
first as a warning, and then
Mhm.
go full on.
Yep.
It would just add some interest to what the
Yeah.
micro's doing.
Yep.
All right.
Anything else?
So how close are you to finishing?
Getting there. I got the board all cut out. Now I just gotta assemble it. And then just do a little bit of work with the boost, and then,
And you've tested that, right? You
yep,
showed that.
it works great.
Yep, all right.
Yep.
All right. Thank you.